Next topic, Fourier series. So before going to Fourier series, first we will define what is periodic function. So a function f of x is called a periodic function if f of x is defined for all real x except possibly at some points, and if there is a positive number p called a period of f of x such that f of x plus p equal to f of x for all x. That means a function is periodic if there exists a positive number p such that f of x plus p equal to f of x for all x. Then we say that f of x is a periodic function. For example, if you take f of x equal to sin x, here sin x plus 2 pi is equal to sin x for all x. You know that sin x plus 2 pi equal to sin x for all x. Therefore, sin x is a periodic function with the sin x is a periodic function with the period 2 pi. Okay, so after that we will define Fourier series. So a series of the form a naught plus a1 cos x plus a b1 sin x plus a2 cos 2x plus b2 sin 2x plus etc. that is equal to a naught plus sigma n equal to 1 to infinity an cos nx plus bn sin nx is called a Fourier series. So Fourier series simply means a series of sine and cosine functions. Okay, now we will define what is Dirichlet condition. So under certain conditions, a function f of x can be developed as a Fourier series. That means if a function satisfies few conditions, then any function can be written as a Fourier series. These conditions are called Dirichlet conditions. They are, first one, f of x must be periodic and finite. That is the first condition. Second condition, f of x must be continuous except possibly at a finite number of discontinuities in one period. That means f of x is continuous except for finite number of discontinuity in one period. And third one, f of x must have at most finite number of maxima or minima in one period. That means their f of x can have only finite number of maxima and minima. So these conditions are called Dirichlet condition. That means if any function satisfies Dirichlet condition, then f of x can be developed as a Fourier series expansion. Suppose f of x be a periodic function with period 2l. That means f of x is a periodic function with period 2l means f of x plus 2l must be equal to f of x for all x. And satisfies Dirichlet condition on the interval c plus 2l. And satisfies Dirichlet conditions on the interval c plus 2l, then f of x can be expanded as a Fourier series of the form f of x is equal to a naught plus sigma n equal to 0 to infinity an cos n pi x by l plus bn sin n pi x by l. Okay, where 2l is the period of f of x. Now here a naught, an and bn are unknowns. So if you know a naught, an and bn, we can find Fourier series for any function which satisfies Dirichlet condition. So the constants a naught, an means n equal to 1, 2, 3, etc. An, bn are given by Euler's formula. So this constants can be find by using Euler's formula. So Euler's formula is first a naught is equal to a naught a naught a naught is equal to a naught is equal to 1 by 2 pi integral. Our interval is from c to c plus 12 f of x dx. This is a naught and an is equal to 1 by pi integral c to c plus 12 f of x into cos n pi x by L dx. This is an and bn is given by 1 by pi integral c to c plus 12, that is the interval f of x sin n pi x by L dx. So this is called Euler's formula. So by using this formula, we can find a naught, an and bn for any function which satisfies the Dirichlet condition. So there is a special case. I will define a special case. Suppose f of x be a periodic function with the period 12 defined on the interval minus L to L and satisfies Dirichlet condition then f of x can be represented as a Fourier series of the form f of x is equal to a naught plus sigma n equal to 0 to infinity say a cos n pi x by L plus bn sin n pi x by L, where a naught is equal to 1 by 2 pi integral minus L to L f of x dx and an is equal to integral minus 1 by pi integral minus L to L f of x cos n pi x by L dx and bn is equal to 1 by pi integral minus L to L f of x sin n pi x by L dx. So this is the special case for most of the questions. We will have a interval minus L to L, or for example minus pi to pi. So now we will do a problem. Find Fourier series. Fourier coefficient of the periodic function f of x, where f of x is equal to minus k if 0 less than x less than 0 and k if 0 less than x less than pi, and f of x plus 2 pi is equal to f of x. So first we will do solution. So given we have f of x is equal to minus k if minus pi less than x less than 0, and k if 0 less than x less than pi. And given that f of x plus 2 pi is equal to f of x. Now first we will find the formula. So here 2l, the period 2l is equal to is 2 pi. Therefore l is equal to pi. So here our function is defined from minus pi to pi, and our period is pi. So here our function is defined from minus pi to pi. Therefore we know uh, we know that f of x is of the form sigma n equal to 0 to a naught plus sigma n equal to 0 to infinity a n cos n pi x by l plus bn sin n pi x by l. This is the formula where we have a naught is equal to 1 by 2 pi integral minus L to L f of x dx. an is equal to 1 by pi integral minus pi to pi f of x cos n pi x by L dx, and Pn is equal to 1 by pi integral minus L to L f of x sin n pi x by L dx. So first we will we want to find out this expansion. So here here L is equal to pi. Therefore first we will find out a naught. So a naught is equal to, by definition, 1 by 2 pi integral, or L is minus pi to pi f of x. F of x is given, so f of x dx. So this is equal to 1 by 2 pi integral, or f of x is defined as minus k when minus pi to 0 and k 0 to pi. So we will define. So first we will find so minus pi to pi. So this is a minus pi to 0. F of x is minus k, right? Minus k dx plus integral 0 to pi k dx. So this is equal to actually 1 by 2 pi integral minus k x minus pi to 0 plus k into x, derivative of integral of dx is x 0 to pi. So this is 1 by 2 pi minus k 0 minus pi plus k into pi minus 0. So this is equal to 1 by 2 pi minus k pi plus k pi. So this is equal to 0. Now, so a naught is equal to 0. So we get a naught is equal to 0. Now we will find a. A is 1 by pi integral minus L to L f of x cos n pi x by L dx. So this is the formula. So this is equal to 1 by pi integral minus pi to 0 f of x is minus k cos n pi x by L. L is again pi, so pi and pi get cancelled, so we will get nx dx, okay, plus integral 0 to pi k into cos nx dx. So this is equal to 1 by pi. Okay, you can take minus k outside, and integral of cos nx is sin nx divided by n, and minus pi to 0 plus k times again integral of cos nx sin nx divided by n, 0 to pi. So this is 1 by pi minus k sin 0 0 minus sin minus n pi, that is again 0. So plus k into, again this is sin n pi 0, sin n pi, value of sin n pi is always equal to 0, minus sin 0 0. So you can, there is n is there, no problem. So this is equal to 1 by pi 0 into 0, so 0. So I get an is equal to 0. So a naught is equal to 0 and an equal to 0. Now finally we have to find out bn. So by definition bn is 1 by pi integral minus L to L f of x sin n pi x by L dx. So L is pi here, therefore 1 by pi integral minus pi to, we want to split up 0 minus k sin n pi x by pi, that is sin nx, plus integral 0 to pi k sin nx dx. This is dx. So this is equal to 1 by pi. You can take minus k outside, and derivative of integral of sin nx is cos nx by n minus pi to 0 plus k times cos nx divided by n, 0 to pi. So this is equal to 1 by pi minus k into cos 0 is 1. 1 by, okay, I can take n outside, so 1 minus cos minus pi. Cos minus pi, that is minus 1 power n. That is cos, the cos of minus n pi is actually is equal to cos of n pi, and the value of cos of n pi depends upon n. When cos n is odd, it will be minus 1, n is even, it will be plus 1. So this is cos n pi is minus 1 power n plus k into minus k by n cos n pi minus 1. So this is equal to 1 by pi minus k by n, 1 minus minus 1 power n plus k by n minus 1 power n minus 1. So we will get 1 by pi minus k by n, and minus k by n is there. So minus 2k by n. So here minus and minus, k, and there is k minus 1 power n by n, and here, okay, so k minus 1 power n, and also k plus minus and minus plus. So you can take k minus 1 power n by n, and here there is k. So this is again 2k. So which is equal to, you will get, you can take an outside 2k by n pi into minus 1 power n minus 1. So Bn is equal to, so we get Bn equal to 2k by n pi minus 1 power n minus. This we get A naught is equal to 0, An is equal to 0, and Bn is equal to 2k by n pi minus 1 power n minus 1. Therefore, the Fourier series of f of x is equal to f of x is equal to a naught is 0, 0 plus sigma n equal to 0 to infinity. An is 0 and 0 cos nx, 0 into cos nx plus bn. Bn is 2k by n pi minus 1 power n minus 1 sin nx. Therefore, f of x is equal to sigma n equal to 0 to infinity 2k by n pi minus 1 power n minus 1 sin n pi x by sin nx. So this is the Fourier series.